In question 1, we have a diagram of a sail pulling a ship at an angle of 40 degrees to the horizontal. In A, we're told the average tension in the cable is 170 kilonewtons. We need to show that when the ship travels 1 kilometre, the work done by the sail on the ship is 1.3 times 10 to the 8 joules. Well, from the formula sheet, the work done is the force times the distance moved in the direction of the force, which is the force times the cosine of theta, with theta being the angle between the force and the direction of travel. Putting in the values, this gives the answer required of 1.3 times 10 to the 8 joules. In B, with the sail and the engines operating, the ship travels at a steady speed of 7 meters per second. In part 1, we need to find the power developed by the sail. Well, power is force times velocity, and this is 170 times 10 to the 3 newtons times the cosine of 40, giving the resultant force in the direction of motion times the 7 meters per second. This is 9.1 times 10 to the 5 watts. In part 2, we need to find the percentage of the ship's power requirement that is provided by wind when the ship is travelling at this speed, given that the power output of the engine is 2.1 megawatts. Well, the percentage is the power provided by the sail divided by the total power, that of the engine plus that of the sail, multiplied by 100. This is 30%. In C, the angle of the cable to the horizontal is one of the factors affecting the horizontal force provided by the sail. We need to state two other factors that would affect the force. Well, the surface area of the sail and the strength of the wind would also affect the force.